Alright guys, just gonna go through a couple of them. If I go too quick, make sure that you pause the video to make sure that you understand it. So the first one, the key information was you wanted the center where it's the same distance from all three maple trees. And the maple trees are these points right here. So because you want the same distance from the vertices of the triangle, what you want is the circumcenter. And to find the circumcenter, what I did here was I perpendicularly bisected all three sides. And let me show you how I did that. Remember, you just got to pick, I'm going to pick this side right here first. And I'm just going to move my compass so that it is more than halfway from that side. I'm going to just draw my arcs. And then once I draw my arcs, I'm going to keep the compass the same exact length. I'm going to go down to right here, the other end point of the line segment. I'm going to draw that one. Okay, so where those two connect, I'm going to draw a line. And also, in red, I'm going to go ahead and perpendicularly bisect this side. Switch it. Okay, so I would use a ruler normally to make sure I connect these, and I'm going to do the one in purple too. Goes from here to here. Now where those two perpendicular bisectors intersect, and let me go and highlight so you can actually see the perpendicular bisectors. That should be the exact same distance from here, here, and here. And that would be your circumcenter. That would be the point where you should put the garden, or I'm sorry, the fountain. Second one, I noticed that here was point P and here was point U. And since the whole circle is 360, I divided 360 by 8 because there were 8, 1, 2, 3, 4, 5, 6, 7, 8 clicks that the fan could go through, or the blades could go through. So I found out that 360 divided by 8 is 45 degrees. So I know that from here all the way down to here is a 180 degrees, so I just added 45 and got 225. This problem, a little bit more complicated. Basically, to reflect something, you know it has to go at a 90-degree angle through the line you're reflecting. So right here, this is the line we're reflecting over. So what I'm going to do is figure out, start at A, and I need to make sure that my two lines, the path that A is going to go and this line are at a 90-degree angle. Well, this line has a slope of 1. So I want to make sure that the path that A follows has a slope of -1. So I'm going to go down 1 over 1. And this would be your new point A. B is the same way. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I'm seeing that from this line it goes a half, 1, 2. A half, 1, 2. So this right here would be the same distance, and that's B prime. Now I would do this for all of them, but what you're going to notice is the relationship of these two distances, they're going to be the same, because when you reflect something, it doesn't change the size of the figure you're reflecting. This one is a rectangular lot is plotted on a coordinate plane. A flagpole is moved from its location 1, 2 to the left 3 units. What are the new coordinates? So remember, if you're going to move it to the left, that means the x coordinate is going to go down 3. So 1 minus 3 is -2, comma, and then y stays the same. And the last one on the grid, translate ABC 6 units down. So we're going to have to do it for every single one. 1, 2, 3, 4, 5, 6. This is A prime. 1, 2, 3, 4, 5, 6. Here's B prime. D is 1, 2, 3, 4, 5, 6. And then C would be right over here. And these are all my new figures. I'm going to go ahead and connect them. And then it says, use mathematics to explain how the translation of 6 units down affects the coordinates of any point. So what you would say is, if you're translating it down, the x is going to stay the same, but the y is going to decrease by 6. And you could show that by showing one of the points. The original B was at 4, 4. But the new point B is at 4, negative 2. So you can see that all that happened was that the y decreased by 6. And that's it.